This video is suitable for students in Senior 5 and Senior 6 who are offering chemistry as part of their subject combinations. So in the previous discussion, I have outlined mechanism 1 or approach 1. However, we can also have another mechanism to this reaction. It doesn't differ much. So in this second approach, I'll come and write my benzene here. I want to react this benzene with chloromethane in presence of a Lewis acid catalyst. Lewis acid catalyst, we saw that the purpose of this is to induce polarity of this bond. Why? It has aluminium that has vacant orbitals, or aluminium which is electron deficient, for the reasons which I have explained in the previous video. Therefore, we can have donation of electrons to specifically aluminium, not chlorine, because it is electron deficient. Now, once this donates, it implies that chlorine has taken electrons and donated them to aluminium chloride, to the Lewis acid. Now, this becomes electron deficient. Since it is electron deficient, benzene is electron rich, it can donate to the methyl group. So this has a partial negative charge and this has a partial positive charge, indicating that it was electron deficient after chlorine taking electrons. Now we form the following. We shall have the following. So we have our benzene ring. It is here. The benzene ring, now it bonds, this bond has been broken, so it is not part. So it bonds with a methyl group. Markovnikov says that this group will go to the nearest carbon that has more hydrogens. But from the structure of benzene, which we saw in the previous videos, this carbon has one hydrogen and also this carbon has one hydrogen. So the methyl group can come here or go there up. So if I put it up, then this is electron deficient. The carbon there is electron deficient. Now chlorine and this aluminium chloride, they have formed this negatively charged ion. That one. Now we lose a hydrogen. There is a silent hydrogen on that carbon, so I expose it and we lose it as a way of donating electrons to electron deficient carbon there. Now once it donates, it also becomes electron deficient. Now this I can lose this hydrogen, or I can bring this so that it donates there. So let me just lose it so that I do not confuse you, given that it is the first example. Minus hydrogen ion. Now if I lose the hydrogen ion, then I form my methylbenzene, and the bond is restored like that. That's what I form. Then the hydrogen ion that has been lost plus the negatively charged ion plus this complex we form. So one chlorine combines with this hydrogen ion, or this simply donates electrons to hydrogen ion, so that we form hydrogen chloride plus aluminium chloride. Aluminium chloride is formed back, implying that it was having a certain purpose. It did not participate directly in the reaction. I am repeating, before I repeat, this video is suitable for students in Senior 5 and Senior 6 who are offering chemistry as part of their subject combinations. If you do not fall under those mentioned categories, there are many videos that have been designed to suit your level. Now I am repeating the examples. I'm having the second example, but I'm repeating the approaches, the two approaches which we have seen in the first example. In this case, we have benzene reacting with bromoethane. In the first approach, we have seen that in the first approach towards the mechanism for the reaction, we have seen that my alkyl halide, which is CH3, CH2, Br, it first combines with the Lewis acid catalyst or the halogen carrier. Now this halogen carrier is electron deficient because it has a central metal atom that has vacant orbitals. Therefore, it can accommodate lone pairs of electrons from other species. So for the reason I explained this earlier on. So this aluminium, after bonding with bromine, it has vacant orbitals. So it needs electrons. So we can have this bromine, since it is more electronegative, it can take electrons from that carbon, then bring those electrons and donate them to aluminium, specifically the central metal atom aluminium. Then what shall we form? We shall form the following. So as a result, we form CH3, CH2 with a plus. This carbon has a plus because its electrons have been taken away. Then plus Al Br4. Now these are 4. These are now 4 because we have added on bromine. They are 4, and this bromine that has been added has come with electrons. That's why you are seeing a negative charge there. Then after forming this, we have now our electrophile benzene. Our benzene ring is going to donate electrons to our electrophile CH3, CH2. This carbon has a plus. So we shall pick electrons from one of the 3 double bonds and donate them to specifically that carbon that has a plus, because it is the one that is electron deficient, not to this one. Then we shall form, we shall have the following. One of the double bond which we have used is broken. However, these ones are still there. So this one is broken. So one carbon forms a bond with, it can come here or they are down because they have the same number of hydrogens. So it forms a bond with CH2, CH3. Note that it is not bonding with CH3 because electrons are being donated to CH2. So it forms a bond with CH2 and CH3. If it goes there up, then this one will be electron deficient. Then we expose the hydrogen here. This hydrogen can donate electrons to that electron deficient carbon. Once it donates, then it is lost. We have minus hydrogen ion. Minus hydrogen ion. Then we form ethylobenzene, CH2, CH3. Now the hydrogen ion that has been lost, the hydrogen ion can combine with our complex. So this donates electrons to this proton so that we form hydrogen bromide plus aluminium bromide. So aluminium bromide is formed back, implying that it didn't participate directly in the reaction. It was just serving a certain purpose. So my products here, I have hydrogen bromide plus ethylobenzene, CH2, CH3. So that is the first approach. That is the first approach. Now I repeat the second approach. In method 2, we have seen that you come and do your benzene. My benzene is here. I want to react benzene with my halogen carrier CH3, CH2, Br, in presence of a Lewis acid catalyst. So this is electron deficient for reasons that I have highlighted earlier on. So therefore it needs electrons. Bromine takes electrons and donates them to the central metal atom that has vacant orbitals. Now once they are donated there, in simple terms, it's like saying that bromine is partially negative and this is partially positive. So this carbon, specifically this carbon which was bonding with bromine, it is electron deficient. Now we donate electrons to specifically that carbon, like that. Then what do we form? The double bond is broken. The double bond is broken. Therefore, we shall have our benzene. This bond is still there, and that one is still there. So this group now is attached to the carbon that has more hydrogens. But from the structures of benzene, which I explained earlier on, this and that, they have the same number of hydrogens. So I can put it up or down. If I put it up, it is bonding with CH2, CH3. Then this carbon has a plus. Then I expose the hydrogen here, so that it donates electrons to that electron deficient carbon. However, once it donates, recall that at this stage here we formed a complex AlBr4 minus. We formed that complex. So in this case, we are losing a proton, we are losing hydrogen ion, as we form our product. Our product by the names of ethylobenzene. So CH2, CH3. The hydrogen ion combines with the complex. In simple terms, this complex is electron rich, it donates to hydrogen, so that we have hydrogen bromide and aluminium bromide. So our product here is the same as we have seen in the first approach. We have ethylobenzene plus hydrogen bromide. So that is the reaction.